Hello everyone. In this video, we are going to see the basics of Numpy. So let's see what is called as Numpy and what can be done using Numpy library. Numpy is numerical Python. Okay. So it is used to do data analysis and some scientific computations. So here the syntax for installing the Numpy is pip install Numpy. Since Jupyter Notebooks comes with a Numpy, we need not install. Suppose if you get an error, you can install with pip install Numpy. So Numpy is a numerical array. The entire Numpy deals with the concept of ND array, or we call it as a numerical array. So Numpy is going to use ND array. Okay, it is n-dimensional array. We'll see what is an array. Array is an ordered collection of similar data items, and these items will be stored in contiguous memory location, which means that in next location. And it will start indexing from 0. Okay, so array is an ordered collection of items, similar items, and which will be stored in the contiguous memory locations, and its indexing will start from 0. Okay, so in this we are just going to see, okay, how to create an array. We'll see how certain operations can be performed in the array, operations on the array. Okay, so we'll see what are the ways to create an array and what all operations can be done on a ND array. Okay, so first we'll start creating the array. So before we start creating the array, we have to import the library. So import the Numpy library. That is import Numpy as NP. So NP is the alias which we create for the Numpy library. So wherever you want to code, wherever you have to use the functions of Numpy, then we can use it np dot. Okay, so first we'll create an array. So we're creating an array. Okay, so array can be created from the list. So first we'll create a list. So let's assume list 1 is equals to, okay, we have some numbers. Then we have to start creating an array. So A1 is equals to np dot, okay, array, and within bracket you have to specify your list 1. Now display A1. So this is your array. So 2, 4, 6, 8 is your array. So let's create one more array. Okay, A2 is equals to np dot array. Okay, you can give the list here only. Say suppose 10, 20, 30. Okay, then we'll display. This is also another way of creating an array, right? So now we'll see what are the different attributes of an array. Okay, so we'll see what are the different attributes of an array. So in attributes of array, we have something like ndim, which is used to check the dimension. We have item size. Okay. We have size. So likewise, we have different attributes in array. So we'll see how are these attributes can be used. We have size. We have type. Okay. These are all the different attributes that we are going to see. Okay, we have all the type. Okay, we'll see one by one now. So the first attribute is what? Ndim. Ndim is what? To find out the dimensions. Okay, to find out the number of dimensions. So ndim is to find out the number of dimensions. Okay, we have created the 1D array. So let's check what will be the size of A2 array. So A2 ndim. So it will tell you as 1, which means that number of dimension is 1. So now let's say we'll create a 2-dimensional array. So np is equals to np array. Okay. We'll create a 2-dimensional array. So 2-dimensional array will be within 2 square bracket. Okay. A3. So this is 2-dimensional array. Now we'll check the size of 2-dimensional array. So A3 dot ndim. So it will tell you it is a 2-dimensional. Okay. So this is ndim. Next is we have shape. That is a second attribute. Okay. Shape. Shape is going to tell you the size of your array. So size of the array. Okay. We can give A2 dot shape. Okay. It will tell you it is 1-dimensional array and there are 3 elements in it. And now we'll check for the 2-dimensional array. A3 dot shape. It is 2-dimensional array. Okay. There are 2 rows and there are 3 columns. So it is telling you it is 2 rows with 3 columns. That's the shape of the array that we are going to use. Next is size. Size is going to tell you, okay, the total number of elements. Total number of elements in the array. Okay. Total number of elements in the array. So A2 dot size. It is 3 because it was a 1 row. Okay, 1-dimensional array. Now it is A3 dot size, which is a 2-dimensional. We had 2 rows and 3 columns. So you will have 6 as your number of elements in the array. Okay, so this is one of the attributes. The next attribute is called as D type. Okay, which is called as D type, which is going to tell you what is the data type of the array. Okay, what is the data type? We have different data types like integer, float, string. So int 32, we have int 64, float 32, float 64, like that we have different data types. So we'll see what is the data type of our created arrays. Okay, so A2 dot D type. It will tell you it is int 34. The A2 array belongs to the integer 32. We'll check for A3 dot D type. That is also integer 32. Okay, now we'll check, we'll create a float array and then we'll check whether it is showing float. So np dot array, okay, 2.0 or something. So we have created a float array. Now we'll check what is the type of your float array. So A4 dot D type. So it is telling you it is belongs to float 64, which means it is a float data type. Okay. Next is we'll see how much memory or how much memory is being allocated. Okay, that is using your item size. So item size is going to tell you memory allocation in terms of bytes. Okay, so let's see a2 dot item size. So a2 dot size is 4 because our data type here it was int 32. So 32 bits. So when you convert into bytes, you will have 8 into 4, 32. So each byte is 8 bits. So it will show you 4 as your size. So every element will be allocated with 4 bytes of memory. And similarly, we can check for the float also. So a4 dot item size. Okay. So it will show you 8 because it was a 64 bytes. So 64 divided by 8, you will get 8 as your size. So this is item size. Okay. So next we'll see how to create arrays in different ways. What are the other ways of creating the arrays? So we'll see that. Other ways of creating array. Okay, so how to convert an integer array to a float array? So that's the first thing. So how to convert int array to float? Okay, so it is nothing. Say suppose n5 is a5 is equals to array. I'm creating an integer array, but I'm going to convert into a float. Okay, so this is integer array 1 comma 2 comma 4 comma 5. Okay, but I'm going to convert into a float. So you have to give d type is equals to float. So whatever data type you give here, accordingly it will convert. So when you display a5, it will show you in the float 1.0, 2.0 like that. Okay, next another way is to create these arrays with zero. So whenever you want to create an array with zeros. Okay, so whenever you want to create an array with zeros, then by default will give you a float array. Okay, so a1 is equals to np dot zeros. So this is the syntax, zeros. Okay, and you have to specify what is your size of your matrix or size of your array. So when you display a1, it will show you 2 rows with 3 columns and everything is filled with zeros. This is one way. And when you want to convert this into a integer array, because by default it is giving you the float array. So when you want to display this in the, then you can just give here as before, d type is equals to int. Okay, and then you display a1, it will show you in the integer 0. Okay, so this is one way, and other one is like getting an identity matrix. All of us know what is identity matrix, right? So you can create an identity matrix. Okay, it's nothing but create an array np dot just give identity. Okay, when you give identity of 3, it means that it will create a 3 cross 3 matrix with all ones. So when you display, okay, only the diagonals will be filled with ones. So that is your identity matrix, right? So a3 is equals to np dot identity into 3. Say suppose you want all your diagonal values to be 666. Okay, then you can just multiply a3 with 6. Then you can check all the diagonal values are with 6. Similar to identity, we have another function called I function that is also to generate or to create identity matrix only. Okay, the syntax to do is A3 is equals to np dot I. Okay, and you can specify whatever size you wanted. So when you display A3, you will get a similar identity matrix but with a I syntax. Next, if you want to create a full matrix, okay, a matrix or an array filled with one particular value, then we use the full. Okay, so we'll A5 is equals to full array filled with one value. Okay, so that will be A5 is equals to np dot full. Okay, what matrix you wanted, say suppose 4 cross 4 matrix, and what is the size, I mean what is the value that you want to fill it with the entire matrix. So A5 when you give, you will get 4 cross 4 matrix with 7 value filled everywhere. Okay, the next is you want to fill the matrix with exactly one value as 1. Okay, like identity matrix, if you have seen, only the diagonal values are filled with 1. Say suppose if the entire matrix has to be filled with 1, then we have something called as 1, okay, which is used to create an array with all one value, 1 as a value. Okay, so syntax for that is A6 is equals to np dot ones. Okay, and then you can specify your array size 4, 5. A6, you get an array with full of ones. Okay, now we can create array with, okay, a range function. We can create an array with a range function. Okay, an a range function will take 3 arguments, that is start, stop, and it will tell you step. So these are the 3 values it will take when you create an array using the a range function. So we'll see what are the different combination we can have. Say suppose a8 is equals to np dot a range. Okay, a range. Now I only give 2 values, that is start and stop alone. So I start with 1 and I end with 10. So when you want to have 1 to 10, then you should give one extra value, because the last value will not be included in the array. So A8. So when you execute, you can see the values are from 1 to 10. So it starts from 1 and it ends up to 11. That is 10. Okay, this is one way. And say suppose you want to create multiples of 5 or multiples of 4. Then you can create like this. A9 is equals to np dot a range. Okay, 5 sorry, we'll start from 1 and we'll go up to 101 with the multiples of 5, and we'll display here what is array. Okay, so here if you give here 0, so it will be in multiples of 5. So 0, 5, 10, 15, 20. Likewise, it will display in the multiples of 5. And if you give only the one value, say suppose here you're just going to give only one value, a range of thing, then it will consider this as your stop value. If one parameter alone is there, okay, then that is a stop value. Okay, it will consider from 0 to 11. So this is using your a range. And there is another way of creating an array, that is using your linspace. So linspace will divide your range of values into an equally interval space. Okay, so that is linspace. So you have to specify how many samples you wanted, and from your starting to stopping position. Okay, the syntax for linspace is np dot linspace Okay, np dot linspace. Then you have to just specify. Okay, I start from 1 to 5. Okay, and I want 4 samples. So the values will start from 1 and it will end with 5. Okay, the last value will be included here, and there will be 4 samples. 1, 2, 3, 4. So it will divide 1 to 5 and then it will show you the average values. That is linspace. Say suppose you want it like this, np dot linspace. Okay, I start from 10 and I go up to 100 and I want 10 samples. Then you can see it is 10, 20, 30, 40, 60, like that. This is another way of creating the arrays. So whatever we have seen till now is the other ways of creating an array. So now we'll go for the different operations which can be performed on the arrays. Okay. Operations on arrays. Okay. So the main condition here is like both the arrays should be of same size. Okay, both the arrays should be of same size. Then only you can do the operations. Okay, so now first we'll declare an array. 2 arrays let us declare. So a1 is equals to np dot array. Okay, let me have a 2-dimensional array. A2 is equals to np dot array. Okay, we have created an array like this. Okay, now we'll do the perform operation. So let's do the arithmetic operation. All the arithmetic operations are allowed here. So arithmetic operations like you can do the addition, you can do the subtraction, multiplication, division, as well as you can do the remainder also. Okay, all these operations can be performed. It is as simple like this: a1 plus a2. This is addition of two matrix. It will just add the first element with first element here, second element with second element, third element with third element. And similarly, you can do your subtraction. Okay, we can give a2 minus a1 because its higher values are there. A2 minus a1. Okay, get it like this. Or you want to multiply a2 star a1, you get it like this. Or a2 divided by a1. Okay, when you want to have a remainder, okay, you get it like this. And you say suppose you want to multiply a1 matrix with you want in exponential power raised to the power of 2, so we can do it like that. Or you want to multiply the second matrix with value 5, then every value will be multiplied with 5. This is another set of operations which can be performed there. Okay, now we'll see about what is indexing and slicing and how we can do it in the array. So let's see. Indexing and slicing. As I said before, arrays are indexed from 0. Okay, so we'll see how indexing is done here. So we'll create an array and then we will do here. So a1 is equals to np dot array, or we'll use a range. Okay, start from 1 to 11. We need a bigger array, so we are giving. Okay, this is an array which is giving values between 1 and 2. Say suppose you want to display the values from 3 to 5. So then you have to use your indexing. So a1 of 2:5, which means that you start from the second position and up to fourth. The last one value will not be included. So 1 is stored in 0, 2 is stored in 1, and 3 is stored in 2. So second position, third position, and fourth position. So we have 3, 4, 5. So we have indexed like that. Okay. Say suppose you want to have your array in the reverse order, A1 or okay, -1. When you give -1, it will show you the array in the reverse order. Okay. Now we'll see how we can do it in the 2D array. Okay. So when you have a 2D array, then how to take a particular column or take a particular row. So we'll create first 2D array. So A2 is equals to A range. I'm just creating an array with A, 21, and I'm reshaping with 5, 4. Okay. Okay, we have already used a two-dimensional array. So we'll see where is our two-dimensional array here. Okay, A1 is two-dimensional array. Okay, this is your two-dimensional array. You want to get one row, the first row alone you wanted. So give it as A2. Okay. The first colon is for the number of rows. The second is for the column. So I want only the first column values to be displayed. Okay. So this is your first column. 8 and 11 is your first column. Okay. So if you want to have like this, 1:1 means first row and the first column. Okay. Okay. This is showing empty. Okay. So this is how you'll do your indexing. So next is transpose. So transpose is converting row into column and column into row. So it is rows into columns and columns into rows. So simply you can just give it as we have A2 array. So A2 dot transpose. Okay, A2 dot transpose. When you give, then the rows will be converted, because here we had 2 rows and 3 columns. So now it will be converted into 3 rows and 2 columns. So this is transpose. And you can sort your array also. Okay, so it's A2 is this. It is already inserted. So we create one array. Okay, let us create one array. A1 is equals to np dot array. Some random values will give. Okay. A1. Now we'll sort this A1 dot sort. Okay, it is sorted in 1, 2, 3, 4, 5, 6. So this is for sorting an array. Okay, we can sort a 2D array also. Right. So now we'll see the last one, that is how to reshape the arrays. So we have different methods for reshaping. So reshaping the arrays, we have lots of functions for reshaping. Here we'll see only reshape. Okay. And then we'll see a Ravel function. And then third we'll see the flatten function. Okay. So first is your reshape. Okay. So the syntax for reshape is A1 is equals to np dot okay. So I have created an array from 10 to 21. Okay, there are 2, 4, 6, 8, 10 and 12 elements are there. So whenever you have a numbers, then accordingly you have to create the rows and the columns. Okay, so now this is there, you have a 12 elements. Now you have to convert this into an array. So I can just put A1 dot reshape Okay, reshape. So we have 12 elements, so I can go for 4 into 3 combination, or 2 into 6 combination, or 6 into 2 combination, any combination which results you in the same set of elements. Now I have reshaped into 2 rows with 6 columns, or you can put it like this. Okay, you can put 4 cross 3 also. Sorry, 4 cross 3. It will show you 4 rows with 3 columns. This is one way of reshaping your array with reshape. And next we have with Ravel and Flatten. So Ravel and Flatten also will be the same exactly. So when you want to do the change the shape, then just will give a1 dot Ravel. So it will flatten your array and it will show you as one-dimensional array. Okay, that is a thing. And third one is flatten. So flatten is like, say suppose a1 is like this, a1 dot flatten. When you give this, also will flatten your array and it will show you as a single dimensional array. So these are all the different ways of reshaping your arrays. Next, we'll go for some statistical operations which can be done on the arrays. So we'll see some statistical operations. Okay. So first we'll do like minimum, maximum, sum, mean, like all that is your some of the statistical operations. So we can see how to find out a maximum element, how to find out a minimum element, the mean, the sum. Likewise, standard deviation, variance, all this can be computed. Okay. So let's see how to calculate. So we'll have an array. Let's have A1 array. Okay, this is A1 array. So now let's find out what is the maximum element in the first array. So just give as A1 dot max. It will just display you the maximum value. Similarly, A1 dot min, it will show you the minimum element in the array. That's 10. Then if you want to find out what is the mean value, just find out mean. Yes. Standard deviation, if you want, just give std. Okay. And you want to find out the sum, you can just give a1 dot sum. So likewise, we can do a lot of operations here on the arrays, right? Next, we'll see something about the random arrays. Okay, how to create random input arrays. Okay, we are going to see in this two functions. One is called as a randint, the other one is the rand. So using these random functions, how we can generate a random arrays. Okay, so a1 is equals to np dot random. This is the syntax. Okay, dot randint. Okay, I start with 5 and I end up to 10, and I need a 10 dimensional 10 cross 10 matrix. And when you display, sorry, so we'll create a random array. Okay, so using random function, we are going to create the random array. Okay, so I'm just creating np2 is equals to np dot random. Okay, randint. Okay, 5 comma 10, then 10 cross 10 is my matrix. Okay, spelling mistake, randint. Okay, A2. So you get a 10 cross 10 matrix, and the values are filled between the values 5 to 10. So all your array values will be between 5 and 10. This is one thing. Say suppose you have not specified anything, then when you say, okay, the same thing here. Okay, when you say it is only E2, it will just create one random value which is less than 5. So this is rand int. Okay, now we'll see for the like random. Okay, using the rand function. So when you use your rand function, it is like this: np dot random, okay, dot rand of 10. It will just generate 10 random numbers, and all the numbers will be between, okay, 0 and 1. So when you display here, random. So a1 is equals to np.random.rand of 10. So this will display a random 10 values, but all the values will be between 0 and 1. So this is how a random function is used to generate the random input arrays. Okay, either using the rand function or using the randint. So now we'll see some more operations which can be performed on the array. That is v stack. That's operation. That is a head stack. All these are basically, we call it as a joining operations, join operations in Numpy. Okay, so how to join the arrays using vstack and hstack functions. So vstack stands for vertical stacking, and hstack stands for horizontal stacking. So we'll create two arrays first of all, and then we will create a then we will do the stacking. So first let me create a bigger array. So data1 is equals to np dot, we'll use the random function dot randint. Okay, randint. I'm just creating from 5 to 15, and my matrix is of 5 cross 3. Okay. Okay, the similar kind of matrix, I'll do it for one more time because we have to stack the same size of the arrays. So data2 is equals to the same size I'm doing it. Okay, I get a different value here, I get a different values here. So now we want to do a vertical or horizontal stack. So head stack is for horizontal. Okay, so you do it like this: np dot head stack. Okay, and you have to specify your two arrays, that is data1 comma data2. Okay, data1 comma data2, and when you run, you can see the rows will be added horizontally. Okay, so horizontal is what? The first row of the first matrix with first row of your second matrix. So here I had 1164, so 1164, and the same row in the second matrix is first row 8512, so that will be added. So horizontally it stacks up both arrays. The same thing, you can do it vertically also. Okay, using vstack, which will join vertically. Okay, instead of hstack, you will just give vstack. So 8, 9, 6, 10, this is your first row, that will be added with your second row. So this is vertical stacking. And next is how to add and remove elements in your array. Okay, so how to add and remove elements in your array. Adding and removing. So you can do adding elements using insert and append. Okay, so insert means it will insert an element at the given position. Okay, insert function will insert the element at a specified location, whereas append will append the new elements at the end. Okay, so this is the difference between insert and the append, right? So now we'll create a new array, np dot array of, okay, 1 comma 2, I have 3 comma 4. I'm just creating an 2D array with 3 rows and 2 columns. Okay, your array looks like this. Say suppose you want to insert a row at some particular location. You want to insert at some particular location. Okay, so the first argument will be your array name, the second will be your position, and third one will be your values. So before it inserts the values into an array, the array will be flattened first, then only it will add. So when you give np.insert, my array name is A1 and I want to insert the values at the position 5, and what is the value that you want to insert is 7 comma 8. So when you do it, you can see that the array will be first flattened and at the 5th position. This is 0, 1, 2, 3, 4. Okay, this is 5th. So in the 5th position, 7 and 8 will be added. Okay, so that is how to add the array, insert an element at a particular position. And we can also append it. So when you append np dot append, okay, a1 array, and simply specify the values, because by default it will go and add at the end of the array. So it is added at the end of the array, that is appending.